Yo everybody, it's 2019 A2 Unit 4 Mechanics section, question number 7, resolving forces. This was a nice easy peasy 5 marks this year. Happy days, hope you get one like this. I got 3 coplanar forces, 8 to the left, 11 down, 21 going up at an angle of alpha above the horizontal. They tell us that tan alpha is 3/4 and they want to know the magnitude of the resultant force. They didn't ask for the direction, but I think I worked it out anyway because I'm a nerd. Right, so this is the main clue. Tan alpha is 3/4. I've nagged you to learn your Pythagorean triplets in class. That means opposite over adjacent was 3/4, which means the hypotenuse was 5, which allows us then to write down that sine alpha is 3/5 and cos alpha is 4/5. I get greater accuracy and I didn't have to use the calculator. So to get the magnitude of the resultant, I'm just going to resolve horizontally, then I'll resolve vertically, and then I will square add root to get the magnitude, right? So let's go horizontally first. So I got 21 cos alpha going to the right, and cos alpha is 4/5, so 21 times 4/5. Maybe I should have put that in brackets. And take away the 8 that's going to the left. Press some buttons on your calculator, that comes out as 8.8. And then resolve vertically. Obviously, if I've used cos alpha horizontally, it'll be sine alpha vertically. So that's 21 times 3/5 going up. Take away the 11 coming down. And that comes out as 1.6 newtons. Now, it wouldn't matter if you'd done it the other way around and you had done left take away right, and these had come out as negative, because of course when you do the magnitude, you square them and then add them and root them, so it would become positive anyway, so don't freak out about that. So horizontally I've got 8.8, vertically I've got 1.6, square, add, root. I've left it as a surd, it'd come out as root 80. Don't forget the units would be newtons, because you are resolving a force. I don't think they asked for the direction, but it's always good to just remember direction is tan to the -1 of the vertical over the horizontal, and that's 10.3 degrees above the horizontal, right? So the actual resultant force would be somewhere going up there like that, right? Now the next bit for 1 mark was a bit stupid. I don't think anybody even attempted it, if I remember. Explain why the forces cannot be in equilibrium whatever the value of alpha, right? And obviously equilibrium means the resultant force is 0. So horizontally I've got 8 to the left equals 21 cos alpha to the right, okay? If I wanted to be in equilibrium, then everything left would equal everything right, which means cos alpha would have to be 8/21. Do the same vertically. If it was in equilibrium, everything up would equal everything down. So my 21 sine alpha going up would equal the 11 going down, which means sine alpha would be 11/21. Okay? And then you just got to use a bit of synoptic mathematics. Don't forget, cos squared plus sine squared equals 1. And if I do 8/21 squared, that's my cos squared, and I do 11/21 squared, which is my sine squared, if I add those up, it doesn't equal 1. So that proves that whatever the value of alpha, it can never be in equilibrium and have a resultant force of 0. Okay? A lot of work for 1 mark, got to be honest, but there we go, I've shown you how to do it. Hope that's cool. See you next time.